So today's webinar, it's a session on the revolutionary techniques for modeling and optimizing complex trajectory patterns. And with me, myself, Rajshekhar Mohan, and with me I have Paresh, who will be helping us on all the demos. DP stands for Detroit Engineering Products. We were founded in 1998. We are the actual creator of DP MeshWorks platform. DP has an in-house R&D team, and it also has its global presence. Our headquarters, it's in Troy, Michigan, and we also have our offices in India, China, Japan, and Brazil. Our distributors are available at France, Italy, South Korea, Canada, and Poland. In DP, we have 4 different groups. The first one is our engineering consulting division. This division does all the services-oriented projects. And the next one is our software development solutions. This is the team which actually works on developing the MeshWorks software. Next is our product development team. They work on developing new products all the way from drawings to a prototype and then manufacturable products. Finally, we have a talent acquisition group, which helps in identifying the right candidates for any of your requirements in and around US and other geographies. Here's a quick view of the DEP team. We have around 160 employees in our North America office, and we do have an office in California. We are available at Brazil. We have 3 offices in India, in Chennai, Bangalore, and Pune. We also have an office in China, Japan, and you can also see our distributors in Europe and Korea. As we speak, we have like 500 plus engineers across the globe, out of which 20% were PhDs, 70% is masters, and 10% were bachelors. Now let's talk about MeshWorks. MeshWorks 2021 is our latest release. It's a CAE parameterization tools which helps you to convert the FE models or CFD designs into a parametric model so that you can perform quick iterations and design of experiment studies. Next is our morphing technology. With the help of MeshWorks morphing technologies, you can get upfront design solution without any CAD, okay? And it also reduces the CAD to CAE and CAE to CAD kind of interaction time by directly taking the legacy models and then utilizing that to your new design. Next is design optimization capability. MeshWorks has a powerful DOE facilitation, and it can help you guys to generate MDO studies and perform quick optimizations. It internally has a parameterization and morphing environment. So if you create parameters on one model, the same can be appended into the other models also. Say, for example, if you are parameterizing an image model, the same can be carry forwarded or transformed into a durability and crash and CFD model. So you only have to do one-time morphing, and that can be carried forward to other disciplines. Next is a process automation capability. As we speak, most of our customers are utilizing our process automation capability, wherein DP will customize and give the tools based on the requirements of the customer's place. And it is easily saving like 70 to 80% of our customers' time on their day-to-day operations. And thanks to our MeshWorks to help us to achieve this. Next is a pre and post-processing capabilities. As we all know, MeshWorks has a pre and post-processing capability. It has a robust meshing module and a very good post-processing capability, wherein it has a lot of automated tools, which also includes the result exploration. Finally, we have released a new capability called ConceptWorks within MeshWorks. This is a tool which helps you to design new concepts. For example, if you're looking at new architectural studies or new concept studies, you don't have to start from scratch. You can directly use our software and try to generate new concepts, and you can quickly reduce the conceptual development time frame in your product development cycle. Coming into the MeshWorks application at different stages, here is a graph which shows, the current trend and the new trend with the application of MeshWorks. MeshWorks morphing and concept modules, when you apply them in the conceptual stage, you can quickly achieve initial concept without spending much time, starting from scratch. So if you look at it at the end of conceptual stage, you will pretty much have like 75–80% of a frozen design. And when you go further into the detailed evaluation phase, MeshWorks parametric and CAE optimization modules will help you to tune up the performance. Finally, when you go for the virtual validation phase, you will only have minimal iterations that needs to be performed. So with the final stage of going to the prototype, you will have the entire process only consuming like 60% of the actual time, which normally you take with the conventional process. Now, coming into the challenges. Being a tire engineer, okay, what are our regular challenges? Okay, for example, if I need to do a hex meshing on tire models, with the current tools in the market, I do have a lot of restrictions, or I need to undergo a lot of training, and I need more experienced guys on building hex models. Is that the real challenge? Or if you're looking for a simplified process to quickly analyze the tire tread patterns, do you really need a full CAD to start your analysis? The next question is like, if you want to make a design change from one design to other, are you really waiting for a CAD engineer to make the changes and give it back to you? Are you really having some struggle in making some quick changes, which are pretty much fine-tuned local design changes on the tread patterns? Is it taking more time? Or looking for a tool which can help you to optimize the pattern and help you to use a lot of DOE kind of studies? And for all these challenges, our answer is, a solution through MeshWorks. So in today's session, we are going to talk about some of the solutions. First thing is the mesh model creation and live demonstration on how you can create a very high quality 2D and 3D mesh model for the tire designs. Next is morphing and parameterization on tires. You can see like how easy it is to create it with the help of MeshWorks. We got to show that live today. And with all these changes, how you can nicely, plan the design for the aquaplaning and do any kind of further optimization study would also get covered. Now, coming into the tire designs. So, with the help of MeshWorks, you can create any type of models. You can create the shell mesh, which can automatically become parametric when you use MeshWorks. You have a lot of sophisticated tools which can automatically generate hex mesh on your complex tread patterns. If you're looking for discrete tire modeling to perform your NVH assessments, yes, we do have a nice process in MeshWorks. Saying all these things, when you come into the MeshWorks excuse me, application, right? If you are planning for studying the air inflation pressure or a response to certain vertical loads or fitment analysis with a rim, those models can be easily generated with the help of MeshWorks on a planar level. Next is our tire modeling process. When you are looking at this, you can see like when you have a CAD section to start with, MeshWorks is a nice process. We only need to pick the CAD face. Then the software will automatically generate the cross section with some internal process of identifying all the cutouts that needs to be imprinted. It will have them all captured in a plane in the CAD, and it will generate a nice cross-sectional mesh. And then you just need to do a top surface mesh and do an imprinting. Finally, you will get a nice hex mesh model exactly matching with the trial design. And here is one example, like if you have a tire pattern available, you can nicely generate that into a hex mesh using our automated hex modeling tool, which Paresh will take you through in today's session. On top of this, when you're looking at some applications like NVH, where your NVH tire modeling is going to be very challenging, we do have a nice solution through MeshWorks. If you have any interest on that, please do ping us. We can also take you through those processes, which internally has some tune-up parameters for optimization. So please try to make use of these opportunities within the tool whenever you have a chance to, test our tool. By saying all these things, I would let Paresh to take it forward with the live demo on the session. Paresh, you can take it forward. Thank you.
Sure. Raj, can you hear me okay?
Yes, Paresh.
Yeah, okay. So once again, thank you so much, Raj. So let's go ahead with the demo. So the first demo would be on 2D FE mesh modeling. So here in front of us, we have a 2D model of a tire for stiffness analysis. So we have this CAD data which we received from the CAD engineer. So the inner portion which you see here on the screen, this is for the pressure load area, and then the outer is for the car cast. Now, the first thing what we need to do is, before we're going to start for the 2D modeling, is we will be creating a nice CAD surface onto this particular CAD curves. So in MeshWorks, it is pretty easy. A user has to define the plane, define the size of it, and just simply click on create. Automatically, a plane will be created, a CAD curve or CAD surface will be created. Now, the second step, what we need to do is we will be imprinting the CAD curves onto the CAD surface. So to do that, it's pretty easy. Again, in MeshWorks, by just selecting the surface and the lines, and simply click on trim. So this would be our first step, where we have all the CAD, where we have the features been imprinted onto the CAD surface. By deleting the extra surface, we just have the CAD surface which we want to mesh. So before going for a mesh, as we can see, all the CAD surface are being organized into a single collector. But in reality, all the different lines which we see on in the between, that is nothing but the reinforcements. So this reinforcement have different material and different properties. So before going for meshing, what we're going to do here is we will be going ahead and organizing this all reinforcement CAD sections into different collectors, so that it would be easy for us afterwards to define the material and property for all this particular, like all these different sections. Now, once the organization has been done, we can directly go in meshing. With the help of the meshing type as mixed, target element size as 2.5, a user can simply go ahead and select the CAD surface and say preview. Now here, this is nothing but our mesh output. And by using this seeding points, we can go ahead and change the seeding points of this mesh so as to get a good and nice mesh output. You can also go ahead and do a quality correction on this particular mesh so as to get a good mesh flow. But we have a unique option, which is called as a move tria in mesh editing, where automatically MeshWorks, automatically when a user clicks on the tria element, it will define a white path, and a user can nicely go ahead and click anywhere on this particular white path where the tria can go ahead and move. So with the help of this tool, what I will be doing is I will just select the select the tria and simply click on the edge. So automatically all the trias are been removed, and we get a very nice and smooth mesh flow. Similarly, if we have opposite trias, so if you see here, What we have to do is we just have to align the opposite trias to each other and simply click one tria onto the another. So we can remove the opposite trias quickly. So likewise, we can go ahead and get a very nice and smooth mesh flow within uh, less time. So which will help us in reducing the model building. Now, the next step is to define the material and property. So I will go ahead and show you exactly how automatically we can define the material and property for the entire components which we saw on the screen. So on the left side, which you see is nothing but the component names. So this component names are exactly same as what we saw in our model. Then each component has been defined by its property type, name, and material. Even we can see the material has been written in front of each and every component's name, the material type too. Now we will open the material table. So here we can see all these materials are been defined with E, density, new, etc. So this is nothing but just a small prerequisite which we need. We just have to fill this data. And once we have these two CSV files available, we can go ahead and do an automation for the assigning material and properties. We can see there are no material and property, and these are the same component names which we saw in the Excel sheet. Now we will be just selecting the component CSV file, material CSV file, and click on create and assign. Automatically within few clicks, in few seconds, the material has been assigned, and then we can see the same names are there which were on in the Excel sheet. Now if I go ahead and click on steel and say show me the steel property, the steel material, and then these are nothing but the rubber material. Similarly, we have some properties. Now in your Excel sheet, there might be n number of properties which might be created. So it will take all the data and it will keep it in a unused or empty. You can just go ahead and remove the unused and empty, and then this is what has been assigned to the respective material and component. That is what we can see on the screen now. So likewise, this is how quickly we can do 2D mesh modeling in MeshWorks. And once the meshing has been done, we can nicely go ahead and assign material and property. Now we can go ahead and create a runnable model in MeshWorks, and we can also go ahead one step further by creating a parametric file, which means that let's say if you have to do any modifications in your 2D FE mesh, what you can do is you can create some morphing parameters onto your component. Now you can see here, if you want to adjust the pressure load, you just go ahead and select the interface and simply morph your mesh, morph your 2D mesh. If you have to increase or decrease the material of the tire, go ahead and increase the outer width. That's what we are looking in front of us. Now, rest of the parameters are for the reinforcements. Now, what if you have to increase or decrease the material for the reinforcement? Yes, you can do that too by just going ahead and creating some parameters. So we just have to make sure that whenever we create these parameters, the profile of the tire is not changing. So that's what we have taken care of. So only the inner elements are moving, but the outer profile is exactly the same. Similarly here, we can go ahead and see different outputs. We can increase the material of the rubber or steel, and likewise we can go ahead and do our optimization study. So this was all about the parameterization of a 2D mesh modeling. Now let's go ahead for a 3D mesh. So what if we have to do a hexa mesh? So here in front of us, we have a cut section of a 3D model, which we got from the CAD engineer, and we just have taken a cut section of it. Now, below we have the tire automation. We have created a special automation for this particular tire trends. So first, let's see how our model looks like. So we have many grooves, as we can see here, and we can see there are a lot of features too in our model. So the first step what we will be doing here is we will be going ahead and organizing our CAD into different collectors. So this will help our next steps to perform well. So basically, to create an hexa mesh for this particular tire trend, we will be following two steps. One, we will be imprinting all the features, or we will capture all the feature lines in one direction. That is nothing but on the side panel. We will mesh the side panel and we will create a mesh where it will nicely have a features been captured. Then the second step is we will capture all the features of the top surface, and then we will mesh the top surface, and then we will imprint the top surface onto the mesh. So that will complete our entire process. So let's go ahead and see our first step. Now, once the organization has been done, we will go ahead to imprint or to capture all the feature lines in the side panel or side surface. So a user has to define the axis, define the center point, then a user has to select the width of the tire tread, then extreme endpoints. So these are a few prerequisites which we need to select before imprinting all the features. And then automatically all the features will be imprinted. And then the surface to imprint. Automatically MeshWorks will create a new CAD surface and it will with all the imprinted. So the first step is to create the CAD surface. Now we can also see there are some grooves which we need to fill it out. So we have created a second tool that is called as fill grooves, where user just has to select the CAD curves of the particular groove. That's all. So by just selecting the grooves, selecting the CAD curves, we can go ahead and fill the grooves automatically. So we will be doing it for the entire model. Wherever we see the grooves, we will be just filling it out. Now, once the features have been imprinted, we will go for meshing. So as we are doing an hexa meshing for this particular component, we need a CAD dominant mesh type. Then the target element size would be 2, minimum is 1, maximum is 4. As per the customer or user, he can change the element size and then he can proceed ahead. Now, once I click on preview, MeshWorks will show the mesh. This is nothing but a preview first. We will be taking help of this particular seed points to get a nice quad dominant hexa mesh. Now, as we can see that there are some seeding points on the right side and left side which are not matching. So what we will be doing is we'll take use of discretized CAD surface. So by just clicking on 2 points onto the CAD surface, it will nicely go ahead and trim the CAD surface. So this will help us to create a good mesh flow for this particular side face. Similarly, we'll be going ahead and selecting different sections, and then we will be trimming the CAD surface. Once the CAD surface has been trimmed, then we will go ahead and with respect to the seeding technique, we will create a nice quad dominant mesh. So this is the first section. Likewise, we will go for the second section too, and then the entire model. So this is the final output, which you can see, which has been covered the grooves too. Now the side mesh has been completed. Now the next step is just to go ahead and create a hexa mesh in the side view. So for that, we just have to define the tire geometry. So automatically, when the hexa mesh has been generated, it will nicely adjust the hexa mesh with respect to the tire geometry. So select the geometry, top surface, bottom surface, and then it will create a top surface mesh, and it will also create a hexa mesh in the background. So there are 2 steps which are going in here, as we can see here. So by selecting the top surface and bottom surface, it has created an additional CAD surface which has all the feature lines. I will delete the feature lines which are CAD surface which are not necessary. And then it also created an hexa mesh. Now, if we see here, the hexa mesh has not been aligned with the particular CAD surface which we just created. So this is nothing but our second step, where we will be creating a same mesh onto the top surface and then imprint the top surface onto the hexa mesh which is below. As we can see here. So we will follow the same process. Select the top surface. Just go ahead and click on preview. And with respect to discretize and show seed points, we will go ahead and get a nice mesh. So now here we'll be just adjusting the seeding points and then just click on map mesh. Then we'll very nicely get a good quad dominant hexa mesh. And this is the final output where the entire mesh is quad dominant and all the features are nicely been captured. Now the last step, to imprint that particular top surface feature line quad dominant mesh onto the hexa mesh. So just by one click, our final output is almost ready. So this is the final output, where from the side view, if you see from the side view, we have nicely captured all the features, and if you see from the top view, we have also captured all the features. So this is a quick way to create a hexa mesh in MeshWorks by just minimal inputs. Now here we also saw that there are some grooves in this particular component which are unnecessary. So you don't have to go ahead and do it manually. We have an option that is called an isolate hexas. So automatically it will detect the grooves and it will just organize it into a different collector. So this is nothing but our final output for the for the 3D modeling of a tire tread. And now once we get a cut section of it, we can go ahead and revolve it with a 360. Now to do the revolve, we have two types. One is a variable pitch and second one is a single pitch. So the example which we see in front of us, it is nothing but a single pitch. But we also go ahead and support the variable pitch, which needs some additional CSV files and additional data. So for this particular process automation, or this particular example, we have a single pitch where user has to select the component, center node, and the axis. Automatically, MeshWorks identifies the angle, and then it will create a revolve 360 nice hexa mesh for us. So this was the entire process of modeling. Now, what if you have to go one step further and create some parametric file for that particular cut section? So we can go ahead and see that too. So let's say, so beforehand we have created some parameters. So the first one is a tire thickness change. So let's say you have to change the thickness of your tire. So what you can do is you can just go ahead and create some morphing with the help of the morphing technique in MeshWorks. You can go ahead and create these parameters. And this all changes are not happening on the hexa mesh. So this is for the tire thickness change. Similarly, we will go for a tire profile change. What if you have to change the profile of the tire? And at the end, it will very nicely go ahead and create the entire 360 revolved hexa mesh. So you can go from a different tire size to a different tire size just for an optimization study. Then we have the tire thickness change. What if you have to change the thickness of the tire? You can do that too. You can play around with the grooves. If you have to change the thickness of the groove, you can create some parameters for that. I'll just zoom in into this location to show exactly how we can modify or morph the grooves. So here we see only the thickness has been changing. And then the next parameter would be for the groove height. This is our last parameter. So here we are not changing the profile, we are not changing the thickness or the width of the tire. We are just increasing or reducing the material of the groove for your optimization study. So this was all about the 3D FE modeling for the tire thread. So as we can see, by using this small process automation, we can go ahead and very quickly create a hexameshing, and also we can create some parameters. So now we want to highlight the key propagations of MeshWorks 2020. Why do customers prefer MeshWorks 2021? So obviously there is a drastic time reduction for model building of mesh models for virtual validation of tires. There is a rapid conversion of FE models to intelligent parametric FE files or FE models. We all were able to see how we can, how by the help of process automation in MeshWorks, we can create a nice process, and this process yield up to 2x or sometimes 10x time saving using MeshWorks. We were also able to demonstrate how nicely MeshWorks can create a parametric model that will help and optimize the tire trend pattern. We can do any optimization. We can do any what if scenarios such as groove depth, block width, sidewall stiffness, and then we can go ahead and create a multidisciplinary optimization to create an optimized design, and it will also reduce the significant cost.